We've been asked to find the slope of the rose curve, r equals sine of 2 theta, at two different places, at theta equals pi fourths and theta equals 3 pi fourths. I've taken the liberty of graphing our rose curve here, just in case it had been a while since we've seen it, and I think we can imagine at pi fourths we're looking for the slope right here, and at 3 pi fourths the slope right there, and I think just from the graph we could probably guess what those slopes are going to be, but we'll go through the work anyway. Now there's a formula in our textbook for finding dy dx for a polar curve, but what I always like to remember is every polar curve I ever meet is really a parametric curve on the angle theta. So I'm just going to write down that dy dx is dy d theta over dx d theta, where x is r cosine theta and y is r sine theta. All right, so for us, r is sine of 2 theta, so x is sine 2 theta times cosine of theta, and y is sine of 2 theta times sine theta. So I'm going to find dy d theta and dx d theta. I have to use the product rule here. So I have the first function times the derivative of the second, plus the second function times the derivative of the first. Remembering the chain rule, of course. dy d theta. Let's see, where am I? Right there. The first function times the derivative of the second, plus the second function times the derivative of the first. All right. So my slope is dy d theta over dx d theta. Well, I'm just going to evaluate this as I go, because I'm asked for it at two specific values. So I have dy dx, I'm going to imagine that theta is equal to pi over 4. And so first on top I need to imagine plugging pi fourths into dy d theta, and so I'll just go through all the trig functions plugging in pi fourths. So here I have 2 times pi fourths on the inside of the sine function. That would be the sine of pi halves, and the sine of pi halves is 1. The cosine of pi fourths is the square root of 2 over 2, plus 2 times the sine of pi fourths, root 2 over 2, times the cosine of pi halves, which is 0. So didn't really need to worry about that part so much. All right, going through dx d theta. All right, got to plug pi fourths into the sine part again. I know that's 1, had a minus out front, so I got a minus 1 times root 2 over 2, plus, well, I think I know what's going to happen here. I'm going to go on and write out the details anyway. But I have 1 times root 2 over minus 1 over root 2 over 2. I should have said root 2 over 2 there. Oh well. In the end, I get minus 1. The slope of the curve there is minus 1. Now, since I've written down these these parametric equations, I could plug pi fourths in and find what x is. I could plug pi fourths in and find what y is, find the equation of the tangent line. In my graph here, I've already done that, and I invite you to do it as well. But there is that nice happy tangent line with a slope equal to minus 1. You can see its equation there. Y equals minus x plus the square root of 2. All right, well, just looking at the symmetry, I think I know what the slope's going to be over at 3 pi fourths. Without doing any calculation, dy dx at 3 pi over 4th, at 3 pi fourths would have to be positive 1. And I invite you now to plug 3 pi fourths into these equations just like I did there to establish that.